Okay, today we'll start with correlations in statistics part. In previous class, we have finished probability distribution, the normal distribution. That was normal distribution. So from today, we'll start correlation part, and this is the first part. Actually, what is correlation? Definition of correlation: what? Correlation analysis deals with the associate between two or more variables. This is the actually definition from Simpson and Kafka. Again, another definition: correlation analysis attempts to degree of relationship between variables. Actually, you must know about the function of two variables. Actually, function means what? The relationship between two variables, y equal to f of x. Correlation means actually relationship, measurement of relationship. Then the third definition: if two or more quantities vary in sympathy so that movement in one tends to the accompanied by the corresponding movement in the other, then they are said to be correlated. This is another definition for this. So from these three we can summarize the definition of correlation like this. Correlation is a statistical technique which help in analysis the relationship between two or more variables. Actually, the correlation between two variables. Suppose actually we are in our weight and height. There is a relationship between two. Okay, weight and height. Actually, if weight if height is increases and weight also increases, that means there is a relationship between weight and height. So we can measure with the correlation, with the help of correlation, this relationship, which is a stable correlation for us. Now there are different types of correlation. One is perfect correlation and another is negative correlation, and this is on the basis of direction of change, negatively direction or positively direction, right? Okay, perfect correlation and negative correlation. Suppose uh, uh, any if we consider any person whose weight is 50 and there is corresponding height, for this weight we'll get height. Suppose after after 1 year or 2 years we want to measure this another, then we get another weight and another height for this person. So there will be a positive if the correlation between weight and height will be will be uh, stable for his body, and this will be positively correlated, otherwise negatively. So the positively correlated sometimes called perfect correlation, or and another one is called negative, not perfect. On the basis of changing proportion, another there are two types correlation. One is linear correlation, another is curvilinear correlation. So on the basis of what? Proportion. On the basis of number of variables studied, there are three types of correlation: simple correlation, partial correlation, and another is multiple correlation. So on the basis of direction change, a positive correlation or perfect, negative correlation. It, if two variables x and y move the same direction, that is if one rises and other rises too, then the vice versa, that means other rises and the one rises. So then if it is called positive correlation. Relationship between price and supply, between money and supply and price, etc., are positively correlated. If demand increases, if demand increases, then price will be also related with this, and supply between money. Okay, supply and price, this is the positive correlation. And negative, if two variables x and y moves the opposite direction, actually increasing in opposite direction, that is if one rises and other falls, and if the other falls, then other rises, then it is called as negative or imperfect, not perfect correlation. So for example, relationship between demand and price. Okay, if demand increases, price Demand increases, price decreases, and if price increases, demand increases. You must know about this. And investment and rate of interest. Rate of interest increases, investment decreases. Investment increases, rate of interest decreases. So this is the actually negative correlation. On the basis of change of proportion, okay, on the change of proportion, change of linear correlation, and other is curvilinear correlation. If the two variables, if we join all points of the line, and we get a joining line, and if the joining line is linear, straight line, okay, then it is a linear correlation. If it is not a constant or but a changing correlation, is said to be curvilinear. If the ratio of change between two variables, ratio not change, will be linear. If ratio change, then curvilinear. Then you can use this example for this types of correlation. Supply of a commodity rises by 20% as often as its price rises by 10%. Then such two variables have their relationship. Then two variables gave a straight line graph. Okay. Price of a commodity rises by 10% and sometimes its supply rises by 20%. Then two variables have nonlinear relationship in this example. Okay. Now on the basis of change of proportion, simple correlation, okay, partial correlation, multiple correlation. Okay, in our next lecture we will study about this more briefly. When we study the relationship between two variables only, it is called simple correlation. Suppose, for example, relationship between price and demands, height and weight, income and consumption. Actually, this is the simple correlation. Now, partial correlation. When three or more variables are taken, but relationship between any two of the variables is studied as constant, then it is called partial differential, partial correlation. So relationship between amount of rainfall and wheat yield. Okay, this is the actually wheat yield means what? Wheat, you must know, this is actually corn, uh, and rainfall, this depends on rainfall. Okay, cultivation of wheat, it depends on rainfall. This is the example of partial correlation. When the study of relationship among three and more variables, then multiple correlation. Okay, if two variables, simple correlation, and if other, if more than two, then multiple correlation. Now degree of correlation. Degree of correlation can be known by coefficient of correlation R. Okay, the following can be various types of degree of correlation. One is perfect correlation, two is high degree of correlation, three moderate degree of correlation, low degree of correlation, and five absence of correlation. This is actually circle. So there is a definition. If you interested, you can tell about this. And now perfect correlation, what will be actually when two variables vary at constant ratio, that means the change will be constant, the same direction, it's perfect correlation or positive correlation. In this case the perfect positive correlation coefficient R will be must be what? Plus minus 1. And for perfect correlation plus 1, and for imperfect or negative correlation what will be? Highest value what will be? Minus 1. Remember it. And high degree of correlation, when direction change is positive, opposite, it is called perfect negative correlation. Okay, then in this case the value of correlation coefficient will be R equals to what? Minus 1. Now for perfect correlation, high degree between this and a positive will be plus 1, and for high degree of correlation this will be between this 0.75 to plus moderate degree plus minus twice 5 to plus 0.75. Lower degree of correlation between 0 and 0.75, and absence of correlation what will be? 0 positive. So negative will be like this for high degree, between minus, just using negative sign. Actually you have to comment for every problem in our next lecture, like this. If the R values this, then it will be what types of correlation we have to write down. Now method of studying correlation, there are different types of method for studying correlation. One is graphical method and another is algebraic method. And this graphical method, actually there are two types. One is a scatter diagram, another is correlation graph. And algebraic method, what? Curl Pearson, coefficient Pearson, and rank correlation, and concurrent deviation method. Actually, we'll try to solve different types of problem using these types of method. Okay, in next class. Now there are what are the types of actually graphic method? Scatter diagram. Scatter diagram. We can draw the scatter diagram using this construction. X variable is represented on x-axis, y variables are on y-axis. Each pair will be indicates the point x and y. Okay, series plotted two-dimensional space like this. Okay, for x value and y value, this point. This is the actually scatter diagram, and this is the actually increase. For increasing x, y also increasing, so it is perfect positively correlated correlation. Understand? And this is perfect negatively, because if x increasing, y decreasing. Understand? If x increasing, y decreasing. This is why it is called imperfect negative correlation. So r will be what? Will be -1, and here r will be what? R equals to what? Actually correlation coefficient. Correlation coefficient. Now high degree of positive correlation, this is the high degree of degree more. This is why there are different types of plot. And high degree of negative will be for increasing value of x, decreasing y. This is why like this. And zero correlation, what? Actually zero correlation means no, there is no relationship between two variables, no relationship between scatter. Okay, so this is the example of zero correlation. Now correlation graph. Correlation can be determined with the help of correlation graph. Under this method, two curves are drawn by making the time, place, serial number, etc. on x-axis and other values of both correlation variables series on y-axis. The degree and direction of is judged by the basis of these curves on the following way: A and B. Actually, this is the and is the x on x-axis 1992, 1993, y-axis. For the first for different types of years, we get the value of x and y here, and value of x another. There are actually two types of series. One is series 1, this color, and series 2, another color. If curves both rises move up or down in the same direction move up. This is the first series, and another is second series. If the curves both series moves in opposite direction. Okay. Now next, algebraic method. There are different types of method for solving correlation. Um, Now Carl Pearson's coefficient of correlation. Carl Pearson's coefficient of correlation. If it is a quantitative method of measuring correlation, this method is known as Pearson's coefficient of correlation. This method has the following main characteristics. One is knowledge of direction of correlation, and another is knowledge of degree of relationship. Ideal measure, covariance. Okay, there are four types of characteristics. One is knowledge of direction, whether it is positive or negative. First of all, we have to find out, is it positive or negatively correlated. Another was, we can measure the correlation quantity of range -1 to +1. We have to measure this range. Another one, it is based on mean or standard deviation. Ideal measure, actually which is one based on mean or standard. Another one is covariance. Carl Pearson's methods is based on covariance. The formula is given by this. We'll use this formula in next. To calculation Carl Pearson's coefficient of correlation, you have to use this formula. R equals to what will be actual mean method. R equals to summation xy, summation x square, summation y square, or this, where x and y are the arithmetic mean of the series. Now deviation of x series denoted by x, and deviation of y series denoted by small y. And deviation of two series are squared and added up to summation x square and summation y square. And this is the assumed mean method. Okay, r equals to n. This is the formula we have used. We will use in our next example. R equals to n into summation dx dy, summation dx dy, square root this, square root this. Where n is the number of pairs of scores, summation dx dy will be the sum of the pair of the deviation from the assumed mean, and dx summation dx will be only variable x series mean. x minus x. Similarly, summation dy and summation dx square, summation dy square. And this is the method based on the use of actual data. This is the formula we need to use. Now, covariance variance method. Covariance of xy divided by variance of x square root variance of y. This is the R equals to another formula for Karl Pearson's correlation coefficient. Now, calculation of coefficient correlation of a group data. We have to use this formula for a group data. For different, we will use this formula in our next example. Now, properties of the coefficient of correlation. Limits of the coefficient of correlation will be -1 to +1. Remember this. Change of origin and scale. Coefficient of correlation is independent of a change of origin and scale. This is the actually does not depend on origin and scale. Scale means range. Now, geometric mean of regression will be can be represented by this formula R equals to square root over bxy byx. Correlation, what is correlation? And this is the example. The yield of crops varies with the amount of rainfall. If rainfall increases, okay, the crops will be increases amount of crops. Types of correlation we have studied in our slides. Negatively correlated, linear, perfect correlation we have studied this with this example in our slide presentation. A scatter dot diagram also we have studied. Okay, method of determining simple correlation, we have studied this method in our slide. And Karl Pearson's coefficient of correlation are equals to this. This is actually formula for finding correlation coefficient of Karl Pearson's are equals to summation xy divided by square root summation x square into summation y square. This can be represented as p equals to sigma x sigma y. Sigma x means what? Variance of x, and sigma y what? Variance of y. Where capital X equal to small x minus x bar, capital Y equals to y minus y bar. Remember it. So now the calculate the coefficient of correlation between x and y series from the following data. You can calculate this example. Now this is given summation x minus x bar whole square equal to 136, summation x minus x bar y into y minus y bar equals to 122, and summation y minus y bar whole square will be 138. Now here summation x square equals to this actually. Okay, summation x means what? X minus x bar. We have to remember this notation. This is the notation of formula of Karl Pearson's coefficient of correlation. Remember it. So capital X will be what? X minus x bar. This is the capital X square, and capital Y square this, and capital XY what? This. Just we know R equals to what? Correlation coefficient of Karl Pearson's R equals to summation xy divided by summation x square root summation x square root summation y square. Using this formula, R equals to what? 0.89. Actually, R value what? Positive, right? And this is the greater than 0 and less than 1. So this is the perfect correlation, and this is the actually positive correlation. Understand? We have to comment it. Without comment, one marks will be less. Remember it, 1 marks will be deducted. So this is the positively correlation, and we have to comment it. Now try to for a discrete data. 10 students got the following percentage of marks in economics and statistics. Their roll number, actually 10 students, roll number, marks in economics this, and marks in statistics this. Calculate the coefficient of correlation. Let the mark of two subjects denoted by and x and y. Okay, and mean of the x, that means taking sum of all 10 subjects of economics, 650 divided by 10 students, 65, and y marks average what will be 66 only. So if we can tabulate it, the given data, if x and y are the deviations of x and y's from their respective mean, then the data is given by small x will be these given numbers of economics, and give y equal to given numbers of statistics. Capital X what will be? X minus x bar. X minus x bar. X bar means what? Mean of x. And capital Y equals to y minus y bar. Y bar means what? 66. Okay, mean. Y bar will give the result. Now this squaring this, we get this column. Now squaring this, we get y square column. Now just multiplying these two column values individually, we get xy column. Okay. Now taking summation, just summation x square will be this, summation y square will be this, and summation xy will be this. So the curl Pearson's coefficient of correlation will give by this formula. Just using formula, we got what? 0.78 correlation coefficient. Okay, and it is perfect correlation because positive correlation. We have to comment it. Okay, similarly you can solve this example, example 5. This is the mathematics marks and statistics marks. There are 8 students. uh, so similar process, using the similar method, we can find out the Carl Pearson's correlation coefficients R values. Actually, there is actually a little bit different. Let the marks of two subjects are denoted by x and y, and this is the x column, mathematics column, and this is the statistics numbers column. And x dash, capital X dash should be x minus 35 mean. This 35 what actually? This is the assumed mean. And this 17 what? This 17 this. Okay, assumed mean. Just highest value what? The highest value 25, right? 25, and lowest value what? 8. Now take average of these two. Take average of these two. Near to 17, right? Near to 17. Now another value, another is 45 highest and 25 highest. Add this, we get 70. That means dividing by 2, we get 35. Actually, this is the assumed mean, right? Assumed mean, and you have to use assumed mean method for the correlation coefficient of Carl Pearson's. Okay, this is the assumed mean method I have shown you in slide. Now x dash will be x minus x bar, y dash means y minus y bar. This is the x dash whole square, y dash whole square, and is the x dash y dash, and this is the actual summation. This to indicate total sum. Now we know r equals to what? Summation x bar y bar divided by n minus summation x dash whole. This is the mean. Okay, this is also, and this is the xy. This is the formula of correlation coefficient of Carl Pearson's. Just using the values from the table, we get 0.980. Very perfect positive correlation. Okay, very perfect. And this is the positive correlation coefficient. You have to comment it. The coefficient correlation from the group data. Okay, same formula. This is the summation as for group data. There will be a frequency multiplied. Okay, just multiplying with a frequency. There are without frequency. Okay, just without frequency. Why? Because it is discrete data. Understand? This is the discrete data. This is why what? Ungrouped data, and this is the for group data, and in every group data there is a frequency. So we have to multiply frequency in every term in the formula. Okay, then this will represent the correlation coefficient of Carl Pearson's for group data. Okay, where r is the coefficient correlation, and x dash will be deviation from assumed mean. That means x equal to x minus a. A means what? Assumed mean. And y bar means y dash means deviation from assumed mean. That means y equals to y minus b. B is the assumed mean for the y data. Now n is the total number of items. That means total number of frequency. Now let us consider this example for the group data. Find the coefficient correlation between age and sum of assured from the following table. Age group 20 to 30, and sum assured in 10,000 and 20,000 this, 30,000 this, 40,000 this, 50,000 this. No person will be this number. Between age 20 this row, and between age 30 to 40 this row, and between 40 to 50 ages this, and between 50 to 60 ages this. Okay, now total, this is the 17, this is the 27, this total for 40,000 total, for 50,000 this, for no person 100. So actually number of persons this. Okay, total person what? 21, total person 33, actually total person what? 100. So n equals to what will be? N equals to what will be? Do you know? n equals to what will be 100. Now let us take x and y as the a's. X dash what will be x minus 30,000 divided by 10,000, and y dash will be y minus y bar. X will denoted by azure, sum of azure, money, okay, and y will be aged. Y will be taken as age and x will be the denoted by money. So x will be what? X minus 30. 30 is the in middle. Okay, assumed mean. Assumed mean of money what? 30,000. Okay, and there are interval what? 10,000. Interval what? 10,000. Increasing by 10,000. This is why x minus 30,000 divided by 10,000. And y dash will be what? Y minus 45 will be assumed. Total actually average will be 45. This is the assumed mean. Now total will be what? Difference between this age, what will be? Length of the class interval 10. This is why y dash equals to y minus 45 by 10. Now r equals to, we know this formula for group data where n equals to summation f, same words. Now putting the values of one in one from we get, and we get x dash will be this, and this is the 10,000, 20,000 column, 30,000 column, 40,000 column, 50,000 column, and this will be the 20 to 30 age rows, 30 to 40 age rows, 40 to 50 age rows, and 50 to 60 age rows. Now x dash column, this is the y dash column, y dash row, and these values given x dash will be this, y dash will be, and this is the y dash, and f column, f into x dash y dash, f equals to this, and then x dash y dash will be this, for f equals to 3, 15, 12, 2. Okay, 3, 15, 12, 2, this third column just. So 4, 2, 3, 8, 4, 2, 3, 8, this is the first column, this is the second column, this is the third column, and this is the fourth column. Okay, and this is the fifth column. For individual values, we get just using this formula, x dash equals to this formula and y dash equals to this formula. For every value, putting x equals to this 16 what? X dash y dash value 16, x dash value and y dash value, x dash value, y dash value, what? X dash value minus 2, minus 1, 0, 1, 2. Okay, and y dash value what? Minus 2, minus 1, 0, 1. Now x dash into y dash what? Minus 2 into minus 2. X dash into y dash minus 1, this minus 1. This 0 multiply this 0. 1 multiply 1. Actually look like checkerboard. Okay. Then taking summation f will be total sum and 17, total sum 27, total sum 32, just taking sum, total sum 20, total sum only 4, and summation x bar. Okay, summation x bar will be minus 34, and here summation x bar minus 27, and this is the summation fx bar. This is the summation of x. F into y bar will be this, f into y bar square this, f into x bar y bar this. Similarly, summation of x square, just taking a square. Okay, fx bar minus 34 from where? F equals to what? F into x bar 17, x bar what? X bar minus 2. Minus 2 into 17 minus 34, minus 1 into 27, this 0 into 32, 0, 1 into 20, this, just like this. So summation f of x square will be this. What will be? X square means what? X bar whole square means what? X bar whole square means minus 2 whole square into f 17. That means 4 into 17, 68. Minus 1 whole square into what? Minus 27. That means minus 27. 0 whole square into 0, 0. 1 square into 20, this 2 square into 8. 2 square means what? 4. 4 into 8 what? 2 square means 4. 4 into 4 what? 16. Similarly, f x dash y dash will be this, and this comes from by using this whole table. Just putting in the previous formula of Carl Pearson's correlation coefficient are equals to this. We get, multiplying numerator and denominator by 10,000, we get this result. Actually negative correlation. Hence, the age and sum assumed are negatively correlated. That is, the age goes up and the sum assumed comes down. That means when age is growing and total sum of assumed will be down. This is the comments of this problem.